Hello everyone, welcome to the Let's Crack It GATE ESE Mechanical YouTube channel. This is your Sathyamoorthy sir. In this session, in this YouTube video, we are going to discuss about gears and gear trains. So there are different parts we are going to discuss for the gears and gear trains, right? So one by one we are going to discuss gears and gear trains. First, what is gear? So we are going to discuss about the gears. Gears are, I think most of us are already aware of the gear things. Gears are toothed wheels used for transmitting motion. So what are the things we are going to discuss in the gears and the gear trains? The things in part 1, part 2, part 3, part 4. There are four parts we are going to discuss. In this what we are going to discuss? Concepts, example problems, and followed by we are going to discuss all previous year 20 years GATE questions, 20 years GATE PYQs, previous year questions. So these are the things will be discussed in the gears and gear trains series. Today we are starting the first one. Gears are toothed wheels used for transmitting the motion and the power. Not only the motion, as well as it transmits the power from one shaft to the another shaft. They are not too far apart, and when a constant velocity ratio is desired. In addition to transmitting the motion, it's not only transmitting the motion. Gears are often used to increase or reduce the speed. It may be the speed from the one shaft is transmitted to the other shaft with increasing manner, or we are reducing the speed. Gears are used to increase as well as reduce both. If the speed is transmitted from the smaller gear to larger gear, so the speed will be reduced. If the speed is transmitted from the larger gear to smaller gear, then speed it will be increased, right? So to increase or to reduce the speed or change the direction of motion from one shaft to the another. One more thing, to change the direction of shaft. Then gear drive is called positive drive because there is no slip in between the gear wheels. So the gears are positive drives. If the gears are engaging together, there is no slip in between the two mating gears. In case if you use two rollers or sometimes belt drive, it may slip. So we can't say it's a positive drive. But gear drives are positive drives while comparing with the other drives, right? In any pair of gears, so guys, I'm giving all the handwritten notes here, then you will get the detailed explanation for all the gears and types as well as for the example problems followed by previous questions. If you watch this YouTube series, the series of classes for the gears and gear drive, 200% easily you can crack the GATE as well as ESE and the state level competitive exams also. The engineering related competitive exams, you can crack the gears and gear trains related questions. I will make you master in the gears in this series of classes. First, what we need to do, so we need to understand the basic things related to the gears and its terminologies. Okay. In any pair of gears, the smaller one is called pinion and larger one is called gear or wheel or puller gear, wheel or puller gear, irrespective of which is driving gear. and we are not differentiating or correlating the gears pinion as well as gear wheel, not depending upon the driving or driven shaft. It's completely depends upon the size of the gear. If the gear is smaller, it is called as pinion. If the gear is larger, we are calling it as gear or wheel. So larger one always gear wheel, smaller one always pinion. When pinion is driver, when the pinion gear is driver, right? When the pinion is driver, the result in step down driver. That means the speed is transmitted from the smaller gear to larger. When the speed transmission, and smaller to larger, then speed reduced, speed is reduced. So it is called as step down driver. When the speed transmission larger to smaller, the speed is transmitted from the larger gear to the smaller gear, then speed increased, the first shaft to the second shaft. What kind of gear it is? Do you aware of the things? Yes, it's a step up when the gear is driver. When the gear is driver, it results step up drive. When the pinion is driver, it belongs to the step down gear, and in which the output speed increases and the torque decreases, and the torque and speed are inversely proportional. When the speed increases, torque decreases. Whenever torque increases and speed decreases, it's a vice versa manner. It belongs to the vice versa things, right? I think you all are aware of it, the things. Basic. Okay. Next. I hope it's clear, right? It's a simple spur gear. I will show you the spur gear details and everything. Students, in case you are having any doubt while I am explaining the concepts, please ping your doubts here. Next, classification of gears. There are two major classifications. Classification based on relative position of the shaft carrying the gears. The two shafts are there carrying the gears, driver as well as driven gears, right? So depending upon the position of that particular shaft, then the gears are classified as parallel axis gears, intersecting axis gears, and non-parallel and non-intersecting axis gears. Second classification, the second part, classification based on the type of meshing of gears, external gears and internal gears. External gears and followed by the internal gears. Is it clear now? Parallel axis gears, I will show you. Parallel axis gears, spur gears, helical gears, herringbone gears, track and pinion. I will show you what is the difference in between these four gears and what significance we are getting in the applications. I will show you. Then intersecting axis gear, straight bevel gears, spiral bevel gears. Non-parallel and non-intersecting axis gears are skewed axis gears, hypoid gears, worm and worm wheel, spiral or crossed helical gears. In the classification based on the type of meshing, external gears and as well as internal gears. There are two types, right? Now, classification of gears based on the relative position of the shaft carrying the gears. First one, parallel axis. First one in this part, parallel axis, spur gear. First type is spur gear. In the spur gears have the teeth parallel to the axis of the rotation. And if you consider, so this is the axis of the rotation. Now the teeth also, it's parallel to the axis, right? It's parallel to the axis. Yes or no? Then transmission between the two parallel shaft, they are used in high speed and high load applications in all types of gear trains. In all types of, maybe in simple gear train, compound gear train, riveted gear train, or non-riveted. I will explain the types of, there is different types of riveted, cycle and everything in the forthcoming videos, right? Which is per gear. It's normal. Look at this condition. In side view, it's an axis. Now the gear to this, it's parallel to the axis, right? So it is called as spur gear. Next, helical gears. Helical gears, it has teeth inclined to the axis of rotation, and they are used for transmitting the motion between the two parallel shafts. The same, all the gears, spur gears, helical gears, herringbone gears and double herringbone gears, all used to transmit the power in between the two parallel shafts. But in the helical gears, the shafts are parallel, but the gear teeth inclined to the axis. Gear teeth are inclined to the axis. And if you consider this axis, it is the axis, right? Look at this gear teeth. In the previous one, it's parallel. It's parallel to the axis. Here, gear teeth are inclined to the axis. Inclined to the axis. Now, it's a smaller one, always categorized to pinion. Large one is called as gear or wheel. And now, it's a left-handed helix. Here, right-handed helix in the mating gears. Left and right. So, while making it, look at this. Here, it's a mating. Two gears are missing each other. And here, the distance, the vertical distance in between the two adjacent teeth is called as axial pitch. Now, along the pitched angle direction, this distance, adjacent teeth distance is called as normal pitch. Then angle between the teeth to the soft axis, helix angle. Helical gears operate smoother and quieter than the spur gears because of gradual engagement of the teeth during the missing and increased contact ratio. Here, helical gears are used for the smoother as well as for the quieter applications. Next, because of smoother action, helical gears are preferred in high speed and high load applications such as in automobiles and turbines. Always in the automobiles, if you consider the car or bike, obviously we are not liking the sounds, extra noise. So in order to reduce the engine noise, in automobiles they are planning for the next type, that is helical gears. Nowadays now they are using the double helical gears. I will show you. Since teeth are inclined to the axis, in the helical gears teeth are inclined to the axis, helical gears are subjected to axial thrust loads and bending couples due to the inclined teeth. Next one, herringbone or double helical gears. The next type, students, in case you are having any doubt, so please give your doubt in the chat box in the live class. So then I will give you the clarification, right? Herringbone or double helical gears. Herringbone gears, also known as double helical gears, consist of teeth having a right and left hand helix cut on the same plane. Right hand as well as left handed helix cut on the same plane. The drawback of helical gears, the problem of axial thrust. Drawback of helical gears, the problem of axial thrust is eliminated by herringbone gears. One drawback, the axial thrust and bending couples are the drawback. Here in herringbone gears, two axial thrusts oppose each other. Here both left-handed helix as well as right-handed. Left right in the both pinion as well as in the gear wheel. and here the axial thrust in the both left hand as well as right hand legs are nullified each other. Hence the shaft is free from completely axial force, but they are more costlier than the single helical gears. Cost wise, while comparing with the herringbone as well as helical gears, herringbone gears are little bit costlier, but the axial thrust force problem eliminated as well as bending couples also eliminated. One more thing, very smooth action we are getting while comparing the spur gear or helical gear. Next very important part, rack and pinion. In most of the applications we are using the rack and pinion. Rack is a segment of gear of infinite diameter. So if you consider one is pinion, always gear is smaller one, we are considering it as pinion. Samir Shanu made easy notes. You require the notes? I didn't understand, Samir Shanu. You are expecting still simplified notes? Here coming to the point, rack and pinion, the rack always infinite diameter. We can't identify the diameter further, right? When the straight line gears called rack messes with the circular wheel is called pinion. Then the combination so formed is called rack and pinion arrangement. The rack and pinion is used to convert the rotary motion into translatory motion or vice versa, the translatory motion into the rotary motion. The use of rack and pinion can be found in lathes, use lathes, and where the rack gives the motion to the saddle. Now the spur gear rack and pinion, helical tooth rack and pinion, both rack as well as pinion or the helical form in the helical rack and pinion. It's a rack and pinion. Now intersecting, second in the classification of the gears based on the shaft carrying the shaft axis, that is shaft carrying the gears, and parallel axis we have completed it. And now intersecting axis. In the intersecting axis gears, bevel gears are used to transmit the power between the two intersecting axis, that is shaft axis. In spur gear, parallel, herringbone parallel, helical parallel, rack and pinion also parallel. But coming to the intersecting axis gears, bevel gears are used to transmit the power between the intersecting shaft. Bevel gears are formed by cutting the teeth along the elements of the frustum of cone. What is meant by frustum of cone? So it is called the frustum of cone. Actually cone, this is cone, right? If you cut the cone perpendicular to the axis of the cone, we are getting the frustum of the cone. So the teeth is cut over the cone surface and along the generator. Bevel gears are mounted on intersecting shaft at any angle, although 90-degree shafts are most commonly used intersecting axis. Now the straight bevel gears, so coming to the straight bevel gears, if the teeth on the bevel gears are parallel to the lines generating the pitch cones, they are called straight bevel gears. That means the cone, if you consider the cone surface, it's an end generator. It is called as generator, generating line or generator. So whenever the teeth is parallel, parallel to the generating line, it is called as straight line bevel gears. And mostly consider this axis, shaft axis are intersecting. If you consider two bevel gears, it's an side view. It's intersecting each other, right? This is called as straight bevel gears. Now, in the bevel gear itself, we are getting the mitary gears. How we are getting this mitary gears? When two straight bevel gears are same size, connect two shafts. When two straight bevel gears of same size connect two shafts at right angles to each other, the gears are called mitary gears. The gears are called as meter gears, right? Advantage: the straight bevel gears can operate under high speeds and high loads. The straight bevel gears can operate under the high speeds and high load conditions. Is it okay? And now, drawback: straight bevel gears are noisier in operation at higher pitch line velocities. So it's a drawback. Advantage: so operate in the high speeds as well as high loads. The next part, spiral bevel gears. As like the spur gear and helical gears, spur gear teeth is parallel to the axis, but in the helical gears, teeth are inclined to the axis of the shaft. But the same as like bevel gears as plus straight line bevel gears and spiral bevel gears, straight line, and the teeth are parallel to the generator. Here, the teeth bevel gear are inclined to the face of the bevel gears. They are known as spiral bevel gears. They are smoother in axis and quieter than the straight tooth bevel gears, as there is a gradual load applications and low impact stresses. Spiral gears are smoother as well as it's used for the high load applications. So this is a classification for the intersecting. Spiral bevel gears find the applications in drive to the differential of an automobile. The efficiency is slightly lower than the straight bevel gears, but it's smoother as well as, and it is used for the high load applications. Next one, non-parallel and non-intersecting axis gears. What is the difference in between the non-parallel as well as non-intersecting? So I am giving the difference in between these two, non-parallel as well as non-intersecting. It is called as skewed axis gears. High point bevel gears, look at this, axes are not intersecting. Axes are, while watching this diagram in two-dimensional plane, it is intersecting. While moving to the three-dimensional, in the isometric view, the axis is actually not intersecting, or that means not touching. High point bevel gears, also known as high point gears, are used for right angle in which the axis do not intersect. Used for right angle in which axis do not intersect. High point gears are smaller in appearance to spiral bevel gears, but the axis of pinion is offset from the axis of gears. Spiral gears, but axis of pinion, it is offset, that is not intersecting each other. In general, high point gears are most desirable for those applications involving the speed reduction. So it's completely used for the speed reduction. Okay. The gears are widely used in present automobile driveline power transmission. I hope it's clear. Driveline power transmission. Okay, next. Worm and worm wheel. So what is the worm and worm wheel? So coming to the worm and worm wheel. Worm and worm wheel, also known as worm gears, are used to transmit the power from one shaft to the another, and which are non-intersecting, and their axes are normally right angles to each other. Look at this condition. These axes are right angles to each other, but they are not touching each other. Completely not touching each other. Worm gears can be used for high speed ratio, up to 400:1 speed reduction is possible only in the worm and worm wheel, not in the other gears. Is it possible through the spur gear? How much bigger and the two small gears we need to mess? One more thing, and always the missing gear modules are same. So the diameter to the number of teeth ratio also we need to maintain, right? And it is possible, high speed reduction possible only through the worm and worm wheel. But the speed reduction is possible, or the speed reduction or the step up speed, step up, it's possible in all type of gears, but coming to the ratio, how much ratio we can attain, the maximum 400:1, it's possible in the warm and warm wheel. Warm gear drive are widely used as speed reducer in materials handling equipments. In material handling equipments, materials, it will be moved very slowly over the conveyor, or it may be in the some belt drive through whatever it may be. So it must be moved with very low speed. But while connecting the things with the motor or any other electric motor or with some other rotating elements, the speed is very high. So 400 RPM to 1 RPM means, for example, so we need to use warm and warm wheel in order to attain up to maximum. It's not least one we can take 100:1, 200:1, or 20:1, whatever it may be. But 400:1 possible through the warm and warm wheel. Next, spiral or crossed helical gears. Spiral gears, also known as crossed helical gears or skewed gears, are used to transmit the power between two non-intersecting, non-parallel shaft. Guys, is it clear up to this point? Is it clear? So we have started with the classification of gears and classification based on the shaft axis, position of the axis of the shaft carrying the gears, and parallel axis, inclined axis, intersecting axis, everything. And the second type of classification, type of meshing. We are moving to the type of meshing after this. Crossed helical gears are used to transmit the power between two non-intersecting and non-parallel shaft. The spiral, non-intersecting, non-parallel shaft. The spiral gears find applications in non-intersecting, non-parallel. It's possible in this hypoid also. Non-intersecting and non-parallel, hypoid, warm and warm wheel, spiral also. But the mechanism on the machine tools, car shafts and oil pumps on all IC engines, all small IC engines, we are applying this spiral. Look at this condition. In case of meshing two gears, if you consider the two cylinders are meshing, so it must be converted to the gear format. Next, classification of gears based on the type of meshing of gears. So what type of meshing of gears we are using? External or externally meshing gears. External gears, the teeth of gears mesh externally with each other. The external gears, they are rotating in opposite to each other. If the pinion rotates in anti-clockwise direction, and yes, gear will rotate in the clockwise direction. They are meshing externally and it's rotating in opposite to each other. Look at, it's a pinion, and here it is called a center distance. Center distance in between the two meshing gears. This distance in between the two shaft axis is called as center distance. Now, internally or internal gears, internally meshing or internal gears. In internal gears, teeth of gears mesh internally with each other. Internal gears, teeth of gears mesh internally with each other. The internal gear rotate in same direction. Application: planetary gear drive of high speed reductions, ratios as well as calculations. Pinion, annular wheel, it is called as pinion. This one is annular wheel, right? I hope it's clear. Okay. So these are the classification of gears. Now we are moving into the very important part in the gears. Terminology used in the gears. In order to solve the problems or to understand about the gears and its properties, so we need to know the terminologies. What are the terminologies used in the gears? And now, spur gear nomenclature. Spur gear terms are basic for all the types of gears. So here I am discussing the terminologies based on the spur gear. First one, pinion and gear. A pinion is smallest of two mating gears, and the large one is called as gear or wheel. Already we have discussed about this. Next one, pitch surface. Pitch surface is the surface of the imaginary rolling cylinder that replaces the toothed gear. Pitch surface is the surface of the imaginary rolling cylinder that replaces the toothed gear. And coming to the pitch circle, it is the imaginary circle upon which all gear parameters are measured. It is the imaginary circle upon which all the gear parameters are measured. So what is pitch circle? It's a very important nomenclature diagram here. It's a gear teeth. Yes, there are two teeth here. Look at this condition. In this center, while mating the two gears, whatever it may be, two gears or one gear and pinion. If the two gears are the same size, we are taking the meshing of two gears. If the two gears are different size, and gear and pinion. So while mating the two gears, the contact point, it's a pitch point. So the circle drawn through the circle connecting all the pitch point is called as pitch point. The circle passing through all the pitch point is called as pitch circle. From the pitch circle, we are discussing the remaining parts. First, and the distance measured along the radius, from pitch circle to the top of the gear tooth is called as addendum circle. So, addendum, first addendum and dedendum circle. The circle drawn through the top of the teeth is called as addendum circle. The circle drawn through the bottom of the teeth is called as dedendum circle. So the radial distance in between the distance measured along the radius from pitch circle to the addendum circle distance is called as addendum. Same, the distance measured along the radial direction and pitch circle to the dedendum circle is called as dedendum. And addendum plus dedendum, total depth is equal to addendum plus dedendum. Addendum plus dedendum. And coming to the point, it's a working depth. It belongs to the working depth. Now the circle drawn through that fillet portion, the fillet portion of the teeth is called as clearance circle. So now the total depth minus clearance distance is called as working depth. So while mating the two gears and the distance in between the top of the, that is addendum of the mating gear to the addendum of the pinion is called as working depth. Then the distance measured along the axis of the shaft, the tooth length is called as face width. Here the distance in between the two adjacent points measured along the two adjacent points in the teeth. The radial distance measured along the pitch circle direction, along the pitch circle. That is distance measured along the pitch circle from the one end to the other end, tooth thickness. Next one, pitch circle, circular pitch, and the distance measured along the pitch circle from one point of the face to the same on the adjacent tooth is called as circular pitch. Now the space in between the two teeth, it is called as tooth space. and top land, top portion of the teeth is called as top land, and the working surface above the pitch circle is called as face, and working surface below the pitch circle is called as flank. So these are all the, it is called as fillet. The curvature portion is called as fillet. So these are all the graphical representation of the terminologies used in the gears. Pitch circle, it is the imaginary circle upon which all the gear parameters, right? So first we are considering the pitch circle, and with respect to the pitch circle all other remaining parameters are measured, right? Next, and coming to this part, here gear and pinion. Gear and pinion, larger one is called as gear, smaller one is called as pinion. Outside diameter, it's a base circle, pitch circle and addendum circle. So while measuring it, the line drawn through the, the connecting point, it is called as the normal, common normal to the two teeth is called as line of action. The angle in between the common normal as well as line of action is called as pressure angle. The same thing the remaining parts, what we have discussed, circular pitch and circular thickness, top land, bottom land, tooth space, and addendum circle, addendum circle, pitch circle, and everything is the same. Now, pitch circle diameter D. Pitch circle diameter is the diameter of pitch circle. The size of the gear is usually specified by the pitch circle diameter. It's an D, capital D. Next one, pitch point. Pitch point is a point on the line joining two centers of the two mating gears. Two centers of the mating gears are called as pitch point. Look at this condition. Here, the line joining and the contact in between the two mating gears is called as pitch point. Then circular pitch. Circular pitch is the distance measured along the circumference of the circular pitch from a point on the one tooth to the corresponding on the adjacent tooth. Circular pitch formula is equal to pi into d divided by t. Here capital D, pitch circle diameter, capital T, number of teeth on the gear. It's a pitch circle, that is circular pitch. Now we are moving to the diametral pitch PD. Diametral pitch is defined as the number of teeth per unit pitch circle diameter of the gear. That is T, number of teeth divided by pitch circle diameter is called as diametral pitch. Now the product of circular pitch into diametral pitch is equal to pi. Pi d divided by t into t divided by d. d, t cancel. The final solution is equal to it's pi. Module. Module is defined as the ratio of pitch circle diameter to the number of teeth on the gear. Module is defined as the ratio of pitch circle diameter to the number of teeth on the gear. Module M is equal to capital D divided by T. Module is the index of tooth size. Top land. And coming to the top land is the surface of the top of the tooth. Top land is the surface of the top of the tooth. Bottom land is the bottom surface of the tooth space. Bottom surface of the tooth space. Face of a tooth is the working surface of the tooth profile lying above the pitch circle. Flank and working surface of the tooth lying below that. Here it's above, it's below. How it is above and below? Look at this diagram. The surface above the pitch circle is called as face, and per circle it's below the pitch circle is called as flank. Yes, while making the pitch circle, it's a surface. Is it okay? Okay, next. Fillet. Fillet is the curved portion of the tooth flank or the root circle, addendum and everything. Addendum is the circle drawn through the top of the teeth and is concentric with the pitch circle. And addendum is the radial distance of the tooth from the pitch circle to the top of the tube. Redundant circle drawn through the bottom of this gear is called as redundant circle. Redundum is the radial distance of a tooth from the pitch circle to the bottom of the tooth. From the pitch circle to the bottom of the tooth. Next, clearance. Clearance is the difference between the redundum of one gear and addendum of mating gear. Clearance circle. Clearance circle is a circle passing through the top of the meshing gears. Total depth is equal to addendum plus redundum total depth. Working depth. Working depth is the radial distance from the addendum circle to the clearance circle. Tooth thickness. Tooth thickness is also known as circular thickness, is the width of the tooth measured along the pitch circle. Next, tooth space. Tooth space is also known as tooth space width, is the width of the space between the two adjacent teeth measured along the pitch circle. Face width is the width of the ear tooth measured parallel to its axis. Backlash, and the backlash is the difference in between the tooth thickness of one gear and the tooth space of the mating gear. It's always while mating the gears, tooth space is little bit higher than the tooth thickness. Yeah, and the tooth would be have very precious. When the thickness of the gear were equal to the tooth space of the mating gear, then the tooth geometry would have to be very precious to operate. There would be no space available for the lubrication of the tooth surfaces. To overcome these problems, practical gears are made with tooth space slightly larger than the tooth thickness. The difference is called backlash. Larger than the tooth thickness, the difference is called backlash. Is it okay now? Okay. Pressure angle. Pressure angle is the angle between the common normal to the two gear teeth at the point of contact and the common tangent at the pitch point. Common tangent at the pitch point. It is called as pressure angle. Next, path of contact. So what is meant by path of contact? Path of contact is the path traced by the point of contact of two teeth from the beginning to the end of engagement. And length of path of contact. Length of path of contact is the length of common normal cut off by the addendum circles of the wheel and pinion. So these are the common data already with the schematic diagram of the teeth and the mating surface we have discussed. Arc of contact, I will explain this arc of contact everything in the forthcoming videos, so you will get clarification. And arc of contact is the path traced by the point. We will skip it actually while discussing the related arc of contact related problem we are going to discuss. Velocity or speed ratio, very important one. Okay, important. Velocity ratio is the ratio of the speed of driving gear to the speed of the driven gear, that is NA divided by NB, it's equal to TB divided by TA, it's equal to DB divided by DA. T, NA and NB, speed of the driving and driven gears respectively. Speed of the, okay. Okay, fine. Next, TA and TB, number of teeth on the driving and driven gears respectively. DA and DB, pitch circle diameter of the driving and driven gears respectively. Pitch circle diameter of the driving and driven gears respectively. Is it okay now? Yes or no? So yes. Next part. Velocity ratio for the helical gears. velocity ratio for the helical gears. Velocity ratio for the helical gears, so we should consider the helix angle also here. NA divided by NB is equal to dB into cos pi divided by dA into cos pi. Here pi helix angle. Now the gear ratio. Gear ratio is the ratio of number of teeth on the gear to the number of teeth on the pinion. Gear ratio is the ratio of the number of teeth on the gear to the number of teeth on the pinion. Gear ratio G is equal to TG divided by TP. TG divided by TP. So these all are basic concepts. In the next class, we are going to start the previous year questions as well as practice questions. Okay. Now, TG and TP, number of teeth of pinion and gear wheel respectively. And small and capital are pitch circle radius of pinion and gear. Contact ratio. Contact ratio is the length of arc of contact to the circular pitch is known as contact ratio, right? Okay. First I will show you. The things which are Unacademy now come up with some offers to you, right? As well as the new batches also available. I will show all the details to you now, so you will get some idea. Now Padho and Khelo Crack lane with top educators, July 1 to 30 for the mechanical engineering students. Concept based learning for each subject. Take a quiz and check your preparation. Top the leaderboard and get the featured on YouTube channel. Enroll the now. Use the code Moorthy 536 for the enrollment now. Right. But one more very important thing. Special class. We are handling the series of special classes for the learners. So now you can get the benefits. What are the benefits you can watch? Now you are watching in the YouTube, right? But in the Unacademy platform, live interactive classes, polls for the learners. So while teaching the each and every concept, the educators, we are giving the live practice questions in the class itself. So you can, it's a special class, so you can get what are the options you are going to get in the Plus platform. So you can get all the practice in the special class itself. Raise a hand option available, so you can talk to your favorite educator in the live class itself. Never miss your class. Never miss your class. Lecture notes anytime, anywhere. Lecture notes available anytime, anywhere. Daily scholarship test is available now on the Unacademy website. Log in with your number, click on the start learning, select your goal and start the test. Lakshya batch for the GATE 2023 aspirants. So we have started this batch yesterday, July 6th. We are going to start it tomorrow, 25, right? So tomorrow, July 6th onwards, bilingual batch, we start welding by Gaurav Babu at 11 a.m. Use the code Moorthy 536 for the enrollment. Moorthy 536 for this enrollment. So I am handling the complete engineering mathematics. So what I am going to start? Complete course on engineering mathematics. Okay. Complete course on engineering mathematics. Engineering maths for GATE 2023. GATE 2023 aspirants. The start date July 13 onwards. July 13 onwards. Timing at 7:30 p.m. to 9:30 p.m. So I am handling it, right? So I am going to handle it. It's common for all department, all branches students. You can get the benefits through this batch. So the top educators all are teaching, and Pragati batch also for GATE 2024 aspirants. And July 6th onwards, we start with Gaurav Babu, the same welding. Now the features on the Unacademy platform. In the Plus, top educators, doubt clearing, raise a hand. In live class, special doubt clearing class, ask a doubt feature, study notes, test series, physical notes, 1:1, live mentorship program, strategy and study program, live audio interactions during. So these extra benefits, notes to all available only in the iconic subscription. Now, Unacademy has come up with some benefits to the learners. Kind attention Unacademy GATE and ESE aspirants, get the iconic subscription at just addition of, in case you are in the plus, you can make it as iconic by paying additionally 555 per month. Get access to the live classes by the top educators, 800 plus printed and digital notes per branch, unlimited access to the recorded content, priority in raise a hand and ask a doubt feature. Use the referral code Moorthy536 to avail the maximum benefits in the platform. Okay. Next, nothing can stop you from chasing your GATE and ESE dream. Get started with 0% EMI today. Avail loan and no cost EMI for GATE and ESE. Get started with the 0% EMI. Avail loan and no cost EMI for the GATE and ESE. Approval in 2 hours. Minimal paperwork. Flexible tenses available for you. Now, Unacademy GATE and ESE mechanical and chemical subscription, 4 months extra free subscription, and you can save up to 39% till valid till July 7th, 2022. And if you take 6 months, additionally you will get 1 month. If you take 12 months subscription, additionally 3 months iconic you are getting. What you pay only 47,700. What you save 28,000 you are saving, right, for the 12 month subscription. Hurry up to save, and up to 39%. So how can you avail these benefits? Use the code Moorthy536. Use the code Moorthy536 to avail these benefits. To avail the benefits. Is it okay now? Is it okay? Next, Unacademy Plus subscription. Now the 12-month subscription available with monthly payment of 3,272 and iconic subscription with 4,333, and use the code for the maximum discount Moorthy536. The code help you to get the subscriptions with the maximum discount in the Unacademy platform. Okay. Now homework and class notes, click on the Telegram channel, my Telegram channel, join with my channel. There you can get all the homework as well as notes. Okay, so click this link and add it to the Telegram channel. There you can get the upcoming videos updates also. Now, then iconic and plus. In plus, live class, weekly test, structural notes, unlimited access. But along with the plus iconic subscription, additional benefits to the plus, personal guide. Get one-on-one guidance from your top experts. Study planner, customized study plan with bi-weekly reviews. Test analysis. Get one-on-one guidance from the top exam experts. Study materials available. Study material. Specialized notes and practice sets, everything available. Experts guidelines, study booster workshops by exam experts. Study booster workshop by the exam experts. Okay. Okay, thank you all of you. So we are going to start the remaining parts in the next video. Part 2 video, it will make you understand the concepts more clearly. Okay.